Chang'e-6 is the first time for human beings to conduct sampling on the far side of the Moon. It is necessary to conduct scientific research on the geological background of the landing area to deeply analyze these precious samples. Due to tidal locking, the Moon always faces the Earth with only one side, which is known as the lunar near side, while the other side facing away from the Earth is called the lunar far side. The left image is a remote sensing image of the near side of the Moon, and the right image is of the far side. The relatively dark areas are lunar mare basalts that erupted after the Moon's formation, while the bright areas are mainly lunar highlands composed of anorthosite that formed in the early stages. It can be seen that there are significant differences in the area filled with basalts between the near side and the far side of the Moon. There are also many differences between the near side and the far side of the Moon. Here is the lunar elevation data, showing that the near side is relatively lower, while the far side is relatively higher. The thickness of the lunar crust on the near side and the far side of the Moon also differs significantly. Here is the thickness of the lunar crust based on lunar gravity data, showing that the thickness on the far side of the Moon is much greater than that on the near side. To uncover the mechanism of the differential evolution between the near side and the far side of the Moon, it is urgent to conduct exploration on the far side of the Moon, especially to conduct sampling there. To address this fundamental scientific issue in lunar science, China has successfully implemented the Chang'e-6 lunar far side sampling mission. Currently, humans have successfully implemented 11 lunar sampling return missions, yet only Chang'e-6 has returned samples from the far side of the Moon. The retrieved samples will have significant scientific value. Therefore, it is necessary to conduct research on the geological background of the landing area before commencing sample analysis. The landing area of Chang'e-6 not only lands on the far side of the Moon, but also locates within the Aitken Basin in the south pole of the Moon. This impact basin is the largest, deepest, and oldest impact basin on the lunar surface. Based on its elevation and composition characteristics, it should be an elliptical impact basin. Based on the crater counting method for age determination and samples suspected to originate from SPA, it is estimated that the age of SPA is approximately 4.22 to 4.26 billion years old. Numerical simulations of the formation process of SPA indicate that this impact basin has exposed lunar mantle material and formed large-scale impact melt. And the landing site of Chang'e-6 is precisely located at the edge of the exposed lunar mantle. Another noteworthy point is that China's Chang'e-4 rover exploration mission is also located within SPA. Therefore, in the future analysis of Chang'e-6 samples, the results obtained by Chang'e-4 can be taken into consideration for analysis. The landing site of Chang'e-6 is actually located within the Apollo crater inside SPA. Based on the elevation characteristics of the inner ring of this crater, it can be determined that this crater belongs to a central peak crater, whose formation process has further excavated deep materials. Numerical simulations of the formation process of the Apollo crater indicate that a thin layer of lunar crust material is discontinuously distributed inside the Apollo crater, including the rim areas around the landing site of Chang'e-6. Parts of the Apollo crater are covered by later-stage basalt, and the landing site of Chang'e-6 is located on a piece of basalt in the south. Based on the distribution patterns of elevation and mineral composition, we have determined the geological unit boundary where the Chang'e-6 landing site belongs. Then, we extracted impact craters within this geological unit. After rigorous completeness diameter analysis, we confirmed that impact craters with diameters greater than 270 meters have been extracted. Finally, using the crater counting method for age determination, we obtained that the age of the basalt geological unit where the Chang'e-6 landing site is located is approximately 2.5 billion years old. It can be predicted that the main component of the Chang'e-6 samples will be local basalt. However, some younger impact craters in the surrounding area may also eject material from elsewhere onto the Chang'e-6 landing site, which will be retrieved by Chang'e-6. After analysis, we found that it is highly likely that the Chang'e-6 samples include some material from the Apollo crater, particularly the Chang'e-6 crater. Through numerical simulations of the formation process of this crater, we discovered that the maximum depth of the material source area ejected to the Chang'e-6 landing site is approximately 1.5 kilometers. Analysis of the thickness of ejecta from global young impact craters at the Chang'e-6 landing site suggests that the Vavilov crater likely ejected some highland material to the Chang'e-6 landing site. Therefore, the Chang'e-6 may also contain some lunar highland material. The basalt and small amounts of exotic materials in the Chang'e-6 samples are expected to address a series of lunar scientific issues, including the age of SPA, the age of the Apollo crater, and the optimization of lunar impact flux. In summary, the Chang'e-6 samples will provide crucial information for lunar scientific research. This research is supported by the National Key Research and Development Program, the National Natural Science Foundation of China, and other projects. We express our gratitude for their support, and we also thank Greg Michael, a researcher from the Institute of Geochemistry, Chinese Academy of Sciences, for his help in refining the grammar of this article. Finally, we warmly welcome everyone to download and read our paper.
Pursue excellence.